Finishing that today. Let's get started. Who can tell me these formulas? Go. Yeah. Basically, these two formulas are literally just yesterday's two formulas divided by 2. You might think, what's the point of doing this? We are going to be in chapter 4. We're skipping chapter 3. We're going to come back to it. We are going to be finding the areas of sectors and lengths of arcs, which basically means a sector is nothing more than a portion of the area of a circle, and an arc is nothing more than a portion of the circumference of a circle. Yeah. Let's see. Area is pi r squared. So for today, a half circle, that would be divided by 2. Circumference is 2 pi r. Now for a half circle, we'll just divide that by 2, which will just cancel with that 2. So it'll just be pi r. 2 pi r divided by 2. 2 pi r for circumference, and then that basically just cancels. So just pi r. Yes. Now, the book tries to complicate area and sector and arc. Now, there are different ways to look at it, but for our intents and purposes, doesn't it make sense that if you need a portion of a circle, whether it be the circumference or an area, why don't you just find the whole thing and multiply by, like, let's say this one, we needed half a circle. Well, how many degrees are in a circle? 360. So that'd be 360 times 180. I'm sorry, that'd be the formula for area times 180 over 360. Because it'll say something like, what's the area or arc, let's say what's the area of the sector or length of the arc of a circle with a radius of blah and an angle of like 72 degrees. Easiest way to do that, find the entire circumference or area and then just multiply that by the number of degrees that they want you to find divided by 360. And it does the same thing as like just cutting it in half. It finds a portion of it. So like an example of that would be, let's say they wanted an arc length. Now arc length goes with circumference. So the normal formula for that would be what? 2 pi r. It'll say it has a radius of, I don't know, 11 meters, and it only wants 77 degrees worth of arc length. So you just multiply your whole circumference by 77 over 360. And then whatever that gives you is the length of your arc. Yes, well this leads into 4.1. The first thing you have today simply asks you, notice I took these from the end of the section, to find an arc length given the radius and the angle. And that's exactly what we just did. Plug in the radius into your circumference formula, plug in the angle. Now if you fully read the directions, it says, express the length in terms of pi, then round your decimal to 2 places. Well, same thing. You'll still get the same thing. So, let's see. That would be 2 pi r times 45 over 360. Boom. Punch it in. Now, it says in terms of pi, it's always your degrees over 360. Now, in terms of pi, that simply means that you just leave everything. So it'll be 24 times 45. Well, somebody want to help me with that? 24 times 45. Calculator would be fine for that. What? Thank you. This right here, so it's 24 pi over 8, essentially, which is 3 pi. Thank you. That is much easier. So, the arc length is 3 pi, that's in terms of pi, and as a decimal, if you punch that in, it's about 9.42. So, that's the two things. The ones in terms of pi, they should all nicely reduce for you if you punch in the calculator. So, if you punched in 2 times 12 times 45 over 360, it probably gave you 3. It is. And then, so 3 pi, and then, so there's your two answers, in terms of pi. Now the book has a different formula for it. I will. The book has a different formula for it, but to use their formula, you have to do other conversions. So in my opinion, when you find sector or arc length, that's the easiest way to do it. Find your whole one and just multiply by the portion that you need over 360. Questions on that? 24. Oh, 2 times 12. And then James, you told me, he said this reduces to 1 over 8. So 24 times 1/8. Okay. Then of course, I forgot to label that. That would be inches. Arc length is just a length. So blah, 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 blah. Now, this is exactly, we're going to be talking in this chapter a lot about radians. Radians are just substitutions for degrees. Has anybody learned about radians before? No, ever worked with radians? Good. Can anybody put into words why we have a radian? What's the point of a radian? Why not just do everything in degrees? Well, okay, let's think about it like this. You're in your car, okay? Let's say you have a wheel with a 2-foot radius. Is that big for a wheel? Car people? Yeah. I don't know anything about cars. I just know mine has 4 wheels with 2 straps. Oh, and I think 3 years ago, I think somebody got mad at me after a sporting event, probably one of my players, and they stuck gum on my door, and they probably thought this will show them. I never even noticed. Somebody had to tell me it's still there like 3 years ago. I don't. It doesn't matter. No, I washed my car, but by now it's like cemented on there because I never bothered to get it. I just need to get from A to B. I don't really care what I come in. Anyway, it could be a Volkswagen. I don't care as long as you get to from A to B. We're getting off topic. Anyway, point of a radian is to convert angular measures into linear distances. For instance, back to my example before we got off topic. You have a wheel with a 2-foot radius. Let's say the only thing we knew, I can't imagine why you even know just this, but let's say all we know is that from here to, I don't know, Prater Stater, it went 200 revolutions. It's probably not very far. Your wheel spun 200 times, right? Now, if there's 360 degrees per rotation, 200 times 360, that's how many degrees it traveled. That's called angular displacement. We're going to get to more of that in the future, but I'm just explaining where radians come from. So 200 revolutions, each revolution is 360 degrees. That's a ton of degrees, like 72,000 degrees. Well, how far is that? Well, a radian comes from the root word radius. If we know the radius of that wheel, then we can compute the circumference of that wheel, can't we? Yes, we can. So, using the radius, we would just find the circumference, multiply that times 200, and bang, that would convert our 72,000 degrees, or whatever we said it was, 200 revolutions, and it would convert it into a linear distance. And say you've traveled, I don't know, 4,000 yards. I don't know exactly how that would translate. But the whole purpose of a radius is to take angular displacement and convert it to a linear distance. So that's the whole point of what we're doing with radians. And we're going to talk more about them if that seemed a little fuzzy to you. Now, here's another formula for the length of an arc. S equals R theta. And you probably do want to write that down. If they give you the radius and the degree, like those last problems did, I would wholeheartedly just do it the way we just did. Find the circumference, and then find a portion of it using a fraction. But sometimes they won't. Sometimes they'll give you the actual arc length, or in other words, you'll have to solve for either the radius or the angle. And in that case, this formula will make it easier for you. That's the theta. Yes. Theta. I don't know. Theta, I think. Maybe theta. They're Greek letters. Mu, theta, pi. I think this is a Greek number. Anyway, nope, that's not Greek. I take that back. Okay, so we are going to solve here, same kind of thing, except instead of giving you the degree and the radius, they've given you the arc length and the radius, and we have to find what that central angle was. Hold on. Now, here's the thing. When you are given the radius, okay, you're not going to be solving for a degree. By them giving us the radius, they've kind of pre-changed our angle into radians already. So it's not going to make much sense, but here we go. So S equals R theta. S equals R theta. Okay? Divide by 10, and what is theta? Believe it or not, that's an angle. That's not a degree. That is 4 radians. What? 4 radians. Now, believe it or not, that's equal to about 220 degrees. We're going to talk about that in just a second. We're actually going to come back and finish these other two in just a second. But radians, what we're going to be dealing with a lot, because we're going to be converting a lot of angles to a lot of measures. We're going to come back to this slide. Now, we'll come back to that one too. Converting degrees to radians. It's all based on the fact that 360 degrees equals 2 pi. 2 pi is 1 full revolution in radians, hence 2 pi r for the circumference of a circle. That's where that comes from. 2 pi is 1 revolution. So you can reduce and say 180 degrees equals pi, right? Now in chemistry, raise your hand if you've ever had any kind of chemistry. Okay, for the majority of you. It's okay if you haven't. But you know how in chemistry, if they're like, convert 2 miles into centimeters, you have to be like, well, there's so many miles in a kilometer, and there's so many kilometers in a meter or something. You know how you have those conversion charts? Similarly, that's exactly how we are going to convert. Whoa. That's exactly how we are going to convert degrees into radians. When you convert degrees into radians, all you have to do is multiply by pi over 180. When you convert degrees to radians, just multiply by pi over 180 every single time. Well, 45 divided by 180 reduces to 1/4, I believe. So that would be pi over 4. Let me get out my calculator. I'm not going to use a graphing because you guys still aren't going to be able to use graphing on your test. So I won't ever use one in this class. So, well, thank you, but I will pass. 45 divided by 180. No, darn it. 180. 1 short of 45 divided by 1/8, not you, the computer, is 0.25 or 1/4. I don't think I can convert to fractions on this book. Yeah, exactly. So it's 1/4 pi. Yep, it says leave it in terms of pi. Yep. 15, so that'd be 135 times, yes, pi over 180. 135 divided somebody just finish this for me. What is this reduced to? Thank you. Yay. Try number 19. Negative's not going to change anything. Just stick a negative out in front of it when you're done. Sure you can. You can't in like geometry, but you can in pre-calculus. Go in the other direction. That's all it is. Exactly. Exactly. Negative 5/4 pi. Very good. All you got to do. When we convert in the other direction, and when we convert radians to degrees, we do the exact same thing, except instead of multiplying by pi over 180, you do it by 180 over pi. Essentially, whatever you start with is what you divide by. So if you start with degrees, you divide by degrees. If you start with radian, you divide by radian. That's just the way I do it. So here, things just reduce again. pi pi, 180 over 2 is 90 degrees. Yep, for radians to degrees. Try this one. 180 over pi slash slash 30 and 1. 7 times 30, 210 degrees. You multiplied the last one too. It was just flipped. The last slide we multiplied also, except it was pi over 180, not 180 over pi. And again, if you don't like reducing fractions, no big deal. Punch the whole thing in your calculator. 25. I'm going to multiply straight across. Now, granted, you can't have pi as a button on some of these, so we're just going to multiply it by 3.142. Close enough. That's 7 pi times 180 divided by 6 divided by pi. 3.142. 210. Same thing. So even with a little handheld calculator, you can do these things. Try number 23 and 27. Try 23 and 27, and I'll pick people to say those answers. Converting them to degrees. Spencer, what'd you get for 27? We'll do it now. Do it now. Derek, you got 23 for me? What do you got? 112? 412? I don't know why I can't hear today. 120 degrees. Whenever you got that, Spencer, just blurt it out. I'll let you get the next one there. Give you a hint, it's negative. What? There you go, 540 degrees. Very good. Multiplied it by 180 over pi. The pi's cancel, so really it's just 3 times 180. Questions? I'm sorry? 23. Same thing. Times pi. Oh, just kidding. 180 over pi. Cancel, cancel. 360 over 3 equals 120. Other questions from this slide? I believe the next two slides are actually the exact same thing, or maybe at least the next one. Convert it to decimals. Now, it's important to know, and we're about to go back to that slide where we were dealing with arc length. Radians don't have to have pi in them. That's not a requirement. Pi is just a nice thing that rounds it out. Isn't pi just a number? Yeah. So anytime you use pi, you can just multiply by pi and get a number, right? So that's all they're asking us to do here. Do the same thing, find the radian, but actually multiply it by pi. Don't just leave pi out. So, converting this to radians, that's times pi over 180. And since it wants it in decimal places, you might as well just punch this thing straight in the calculator. Of course, you could reduce that and move your decimal point if you're pretty good with fractions, but you don't have to. 18 times pi 3.142 divided by 180. Gummit, my one button is sticking. 180. Click. 0.3142 is the radian equivalent to 18 degrees. Touche. 0.31 radians is the equivalent to 18 degrees.
You can punch them straight in the calculator. You can do it the same way and by reducing and blah, blah, blah. So, knowing that, well, actually, let's finish this slide before I get into that. Are there questions? Does anybody want to see 31 or 33 worked? Same thing, just punch in the calculator. 31. So times pi over 180. Calculator. 40 with a negative sign. Where's my? That's a minus. Crikey. No, I know there's a minus sign on here somewhere. Use the last one. Right there? Hold on. How do I clear this? Oh, man, you're good with these things. I don't know. Ah! Oh, I bet this one does it. Ah! Negative 40. Negative 40 times pi divided by 180. And you can say that's approximately negative 0.7 radians. Negative 0.7 radians. Well, it wants it multiplied. Well, think about this. What is 1 pi? What's the decimal for pi? 3.14. And that's equivalent to what degrees? 180. So this is, 10/9 of 1 pi. So if you multiply that by 3.14, is that what you're saying? Can you just do that? Well, yeah. We can predict what this is going to be. This is just 20 degrees bigger than 180. So what's something slightly bigger than pi? Like 3.5? You can predict what these are going to be. Yeah. 200 times pi divided by 180. I'm holding out hope for 3.5. 3.49. So you can predict what these things are going to be because you know what pi equals. So, anywho. And then they have another slide where it's basically the same exact thing. They say convert these radians to degrees, rounding to two decimal places. That's no different than what we were already doing. Let's look at 39, however. You don't have to have pi to use a radian. So, converting radians to degrees is times 180 over pi. Calculator. Negative 4.8 times 180. 180 divided by pi. I would highly encourage you to take it to 142. Get more accurate. So that's approximately negative 274.98 degrees. Questions on that? I'm glad you think so. Now, going back to that second slide that we did, hopefully that helps you better understand how a number like 4 radians makes sense. Because we could convert that to degrees, and that'd be approximately 220-something degrees-ish. Which makes much more sense if you think if you're thinking in terms of circles. Same thing for this one. S equals 8, R equals 6. Divide, solve for theta. Doesn't have to have a sign in, none of these will. What about number 11? What's something I have to do in number 11 before I can solve it? Pierce, what do I need to do in number 11? That's right, convert it. How many centimeters are in a meter, Nick? 100. It's always smart to convert the bigger unit. It's easier to deal with big numbers than it is decimals and fractions. So, arc length equals radius times theta, divide, and once again, it is 4 radians. Now you can convert that to degrees to make your mind more happy with an angle, but you don't have to. 4 radians. Questions on that? We're almost done. Theta is your angle. But anytime you're given the radius, okay, your angle's been pre-translated into radians. That's why we're getting such low numbers and not like 220 degrees. Okay, last slide. Real blast from the past. Acute, obtuse, straight, and right. The only thing that's going to be different about this today, well, let's just start with this. Number 1, obtuse, acute, right, or straight? Good. Obtuse is between 90 and 180. Straight equals 180. Right equals 90. And acute is from 0 to 89. I guess I should have written this 179 and 91. I'm going to add one more in here. But first, number 3, acute or obtuse? Acute. 5. Right. Because pi equals 180 degrees. So that would be straight. Let me add one more in here. See if you can get this one. I can answer that if you really want to know. Just a second. 1.82 radians. What is it? And how do you know? You could convert it to degrees. It's the easiest thing to do. Or you could say, what's pi? 3.14. It's less than that. So we know it's got to be less than 180. What's half of pi? 1.57. Is it bigger or less than that? So it's greater than 90, half of pi, and it's less than 180, so it is obtuse. But you could always, you could just convert it and look at the degrees. 1.57. Oh, because they don't change, and we had already done that one. It was right here. Pi over 2 equals 90. These ratios will never change. Pi over 4 is 45. Once you see it once, it'll always be like that. So, anywho, here you go. Let's work hard on this.